Unit 9, Target 4 homework, number 18 says solve the right triangle. I'm going to label my sides using kind of a standard convention, which means that we're going to use a lowercase letter across from the capital letter to represent the side. So lowercase t is really segment RS. Lowercase s looks like the hypotenuse. And then I also want to find angle T. Angle T is going to be the easiest to find. Once you have one angle measure besides the right angle, you can just do 90 minus the angle you have to get the angle you want. So 90 minus 57 is 33 degrees. You don't need to use trigonometry or trigonometric ratio to find that value. So I have 33 degrees. 33 plus 57 is 90. 90 plus 90 is 180. To find T and S, I'm going to use my standard trig ratios. So in class, we talked about finding a side length or finding an angle. We'll determine what type of trig expression you're going to use, what type of trig function. So in orange, I have here, if you have the angle measure, so I have the angle measures, and you're looking for the sides, you're going to use the sine, cosine, and tangent. So if I look at the numbers that I'm given, I'm going to use the 57-degree angle because that's what they gave me, just in case I made a mistake with the 33. I'm going to use the 15, which is the opposite. I'm going to label S as my hypotenuse. I'm going to label T as my adjacent. So my two expressions are going to be this. I can say sine of 57 degrees is equal to the opposite over the hypotenuse. So 15 over S. And I can say that the tangent of 57 degrees is equal to the opposite over the adjacent, 15 over t. I'm just trying to solve both of those. We're going to round to the nearest tenth. Remember that sine 57, tangent 57, those are giving you decimal values. It's giving you the ratio you're looking for as a decimal. We're trying to find the letter, S and T, the numbers that go there, to be those same ratios. For the first one, sine 57 equals 15 over S. I'm going to show you the two steps that get you to what you want. We multiply by the denominator so that it cancels out. We don't want to have the variable on the bottom of the expression. That's going to give me S times sine 57 degrees is equal to 15. And then I want S by itself, so I need to divide by sine 57. Sine 57 divided by itself is 1, and so now I have S equals 15 divided by sine 57. And I can type that in my calculator, 15 divided by sine 57. 17.9 if I round, 17.9 for S. So what we saw right there is that when you're dividing, when your trig ratio ends with a number divided by the variable, in order to solve that at the end, the very last thing I did was the number 15 divided by the trig ratio. So that means for this problem on the right, that T is going to equal 15 divided by tangent 57. And I can type that in. Reminder where that's coming from. It starts by multiplying both sides by T. Multiplying and dividing by T on the right cancels that to a 1. And then dividing both sides by tan 57. So multiplying and dividing by tan 57 on the left goes that to 1. So on the left side I just have a T, on the right side I have 15 divided by tangent 57. Which is 9.7. And then I can use Pythagorean theorem to check that my numbers match up the right way. So T is 9.7, I can say 9.7 squared plus 15 squared. See if that's close to 17.9 squared. So Pythagorean theorem to check that my sides worked out. 9.7 squared plus 15 squared. 319.09. I want to see if that is close to 17.9 squared. 320 to 319, I think that's pretty close. So there you have it.